one concept that is essential to understand is the idea of why we look at measures of central tendency and variation together and not just one or the other. So if a set of data has a small standard deviation, what does that imply about the data? Well, remember, standard deviation measures how spread out the data is, or the variation within the data set. Another way to think about standard deviation is an average distance from the mean. Okay, so the average distance that a data value lies from the mean. Okay, so if a set of data has a small standard deviation, generally what you're saying about the data is that they are close together. Okay, so there's not a lot of variation within the data set. Well, I just want to point out that when we say small or close or large or far apart, it's all relative to the data set that you're looking at. So for example, if you had a standard deviation of 2 pounds, whether you're looking at a group of squirrels compared to a group of humans, like adult humans, that 2 pounds is going to be much larger relative to the group of squirrels than it is to the group of adults. Okay, so you need to really look at the data set in its entirety and not just look at words like close or small or large, because the numbers themselves, like I said, 2 pounds, that could be large or it could be small, depending on what the data is to begin with. Okay, so you just gotta be careful with that as far as using numbers to describe your data. Okay, so an example I like to give is kind of a silly example, is number 2. Suppose you're invited to a party. Determine whether you would want to attend the party if you knew the following statistics for the age of those at the party ahead of time. So think about a set of data that could result in the following statistics. So I suggest you pause the video and think about this question for a minute. And if there was a mean of 20, would you say, hey, that sounds good, I want to go to that party? Now just remember, I'm looking at this from the student perspective, that you're right around 20 years old. Okay, so that's how I want you to think about it. So if you are an older student or a younger student, just think about it in terms of, if this was a 20-year-old looking at this data or looking at these statistics, how would you answer these questions? Okay, so I'm going to go into talking about some of the answers here. Well, with the mean, how can you get a mean that's 20? Well, one way is to get a list where everyone is very close to 20. So you might have several 20-year-olds, you might have some 19-year-olds, 21-year-olds. Well, they would average to 20. So it could be a kind of party that you'd be interested in if everyone was close to that same age of 20, or close to that mean of 20. Well, another way to get a mean of 20 would be if there were many 5-year-olds and 35-year-olds. So there, 5 and 35, if you add them and divide by 2, you would get 20. So for every 5-year-old and every 35-year-old they would average to 20. Okay, so a silly example of that would be maybe a kindergartner's birthday party, where you have parents that are 35 years old and kids that are 5 years old. That party doesn't sound as fun to me as if everyone was 20 years old. Okay, so that's the kind of things you need to think about. Is if you're just given the mean was 20, you might say, hey, yeah, that sounds great, everyone is close to 20. But data doesn't have to work that way. Okay, you could have had 5 and 35-year-olds at the party where those averaged to 20. Now, there could have also been other people there that were around 20, but in an extreme example, I want you to understand that just saying that mean is 20, how you can actually get that mean. Okay, so what about if the median is 20? Okay, so again, everyone may be close to 20. Okay, so the middle number. Okay, so everyone may be close to 20. But it could also happen where you have many younger people, many older people, and it just so happens that 20 is the middle number. Okay, so you could have several people much younger than 20, several people older than 20, and it doesn't have to be symmetric like this. I just drew it that way to make a point that you could have a lot of very young people, like 5 years old, and a lot of older people. Now, how the median is different than the mean is that the median here, you could have had, like you could have people 70 years old up here rather than 35, and the median might still be 20. Okay, if you had 70-year-olds up here for the mean, then that mean would be dragged higher because the mean is susceptible to outliers or extreme values. Okay, so the median, again, a similar thing could happen as what happened with the mean. Okay, what about if the mode is 20? Well, again, everyone may be close to 20, okay, which would be good. But although 20 occurs more than any other age, there may still be many different ages. So you might be in a situation kind of like with the mean and the median, where you have several people below 20, several people a bit above 20, but there might be more 20-year-olds than anybody else at the party. Or you could be the case where there's several 20-year-olds there, so maybe like 4 or 5 years old, and then there's many people that are a bit older. But this value might be like a 50-year-old here, 52 years old, 55 years old, 70 years old. Okay, so there the mode, just because it occurs more than any other data value, it doesn't mean that that's a party you're going to want to go to. Okay, so the point I'm making here is the measures of central tendency, they do tell you stuff about your data. They tell you something about your data. But it doesn't tell you enough about your data. So that's why we also look at measures of variation. So now suppose you knew that the mean was 20 and the standard deviation is 5. So the average age is 20, the average distance from the mean is 5. Well, you're probably not getting the case now where you have several people that are 5 years old and then many that are 35 years old. Okay, that's probably not happening now because the standard deviation is only 5. So the average distance from the mean is 5. Okay, so what that would be telling you is that the data values are much closer together than they are in this first one. Okay, so something else you might want to look at is that if the standard deviation was even smaller, so suppose the standard deviation was 2 instead of 5, and the mean was still 20, well then you're looking at a distribution that is centered around 20, and it's very close together. So what that would mean is you'd have a situation where you'd most likely have a bunch of 20-year-olds and then a bunch of values that are on average very close to 20. So that would be a party you'd want to go to. Okay, and then the last thing is if they told you that you had the mean was 20 and you had a normal distribution, that would also be informative. Okay, now depending how large the standard deviation was, but again, if that was a standard deviation of 5, then the mean of 20 might be okay, because on average, if the distance is 5 from the mean, that would take you to have about 2/3 of the data between 15 and 25. That might not be too bad, but the smaller that standard deviation is, the closer the data set will be to each other. So that would definitely be a preferable party, is if the standard deviation was smaller.